Hi, I want to welcome you to the solar array here at Massanutten Regional Governor's School and Triplett Technical Institute in Mount Jackson, Virginia, a part of the Shenandoah County Public School System. My name is Russ Kors and I'm the environmental science teacher at Massanutten Regional Governor's School. This project you see here began 6 years ago with just a few students at Massanutten Regional Governor's School who wanted to take some of this empty lawn and turn it into a way to farm electrons. A few years later, we were in touch with SunTribe Solar. They took it from there, they built this system, and that student vision became a reality.
Hi, my name is Remy Pengel and I'm with the Center for the Advancement of Sustainable Energy at James Madison University. And we are so excited that Triplett Tech and Massanutten Regional Governor's School have worked together to put this solar array at their school. It is so important for schools to bring renewable energy to their campuses, not only because students are learning about this amazing renewable energy industry, which is going to have a ton of jobs coming up in the future, but also because this school is also able to produce 100% of its electricity from renewable energy sources, which is super important for the environment. Renewable energies do not emit carbon dioxide into the atmosphere. Carbon dioxide is the #1 greenhouse gas attributed to our climate change issues. So solar panels work by absorbing radiant energy from the sun in the form of photons, or little packets of energy. That energy is transferred to the silicon atoms that make up the solar panel. You can see the blue color of the solar panel. That's the silicon, and that energy transfers from the photon to the silicon, and the silicon atom gets so excited it excites the electrons, and the electrons produce electrical energy that we can then use in the school to power things like cell phone chargers, computers, lights, you name it. So we are super excited to learn more about this solar array, so let's go check it out.
Hi, my name is Megan. I'm from SunTribe Solar, and SunTribe did the development and the construction of this solar array. So before any construction happens, our engineers do a lot of analysis. So they take a look at how much energy the school uses to see how big the solar array we need to design. They also take into account any environmental considerations. In fact, there was something special that we had to do at this site because it's so close to the highway. We actually had to do an analysis to make sure that the glare from the panels wouldn't affect drivers driving by. So there's all sorts of considerations that happen before anything goes in the ground. So this is a ground-mounted system. You may have heard about solar panels on roofs, but we can actually put them on the ground here, depending on what the school has available. The solar panels are facing in a certain angle, and that's because here in the northern hemisphere, the solar panels need to face south because they're facing the equator, and that's where they're going to get the most direct sunlight because of the way that the sun moves in relation to the earth. Behind me, you'll see, we call these solar panels, but if you want to speak like somebody in the industry, each of these rectangles is called a module, and they're all wired together, and once they're wired together, that's called an array. So here at Triplett Tech, we have 702 modules that are arranged in about 5 rows of arrays or panels here. So once the racking is installed, you can see that we have big steel racks here, and you'll see that these wires connect the electricity that's being generated from all these solar panels here. After that happens, all those wires are connected into bigger, higher voltage wires, and they're buried underground where they're connected to the school. Of the solar panels and modules are connected, at the solar site, then the wires are put together into higher voltage wires, which you can't see because they're buried underground, but I brought an example here. You can see how thick it is. There's an insulating material on the outside of the wire and conductive material on the inside, so the electricity stays within the wire. Those are protected by conduit, which you see here. And then they flow into what are called inverters. Inverters are important because the electricity that the solar panels produce is in a form of electricity called direct current, and that's what we can use in our batteries. But when you plug something in a school, that uses alternating current. So these inverters work to convert the direct current produced by the solar panels into alternating current, so that the electricity is in a form that you can use at school. I'm actually standing next to these, and you can hear them making a really soft buzz. They're not loud, but if we were to get a really big cloud to come over, you would hear that sound change because they'd be working a little bit less hard. And that's because our solar panels depend on the sun, so when the sun is not as strong, there's not as much as electricity being produced. When it's really strong, these inverters will be working really hard to convert all of that radiant energy into electricity in a form that we can use. The last part of our solar tour is actually not here at the site, it's actually on the computer where we have a solar energy dashboard. So since electrons are invisible, we can't really see or visualize what those solar panels are doing. So this dashboard is here to help us understand how much electricity is being generated. So if you look at the graph on the bottom, you can see exactly how much electricity is generated every 10 minutes. So each little bump that you see here represents a day, and electricity starts when the sun rises. Remember, our electricity source is the sun, and then you'll see it produces more electricity until about the middle of the day, and then that goes down. You'll also see that some days have really smooth curves and some days have really bumpy curves. So take a second to think about why that might be. It has to do with the weather, right? On a cloudy day, we're going to see more bumpiness, and on a really bright sunny day, we're going to see more electricity produced more consistently. Thank you for joining us on our solar video tour here today. If you have any questions or want to do more investigating, please contact either me at SunTribe or
Remy at Case at JMU.